So hello guys, once again I welcome here all of you in this marathon session of environmental engineering, where we'll discuss the numeric portion for the gate examination. And yesterday's lecture we covered water demand. Today we're gonna cover the surface water and its conveyance. And yeah, today we're gonna cover surface water, sources of water and its conveyance. I'm sorry for that. So today our topic is sources of water and its conveyance. Sources of water and its conveyance. Yesterday's in water demand, we calculated that how much amount of water we needed. Today we're gonna discuss about the sources of water, where we get water. Okay, so in this we have a first thing, that discharge from infiltration galleries. So first thing, discharge from infiltration galleries. Okay, for this we have formula. Q is equal to KL H square minus H square upon 2R on 2R. Okay, basically here this capital is static water level, and small h is depth of water. Depth of water. So yeah, this is discharge from infiltration galleries formula. Our next thing is yields of an open well. Yields of an open well. Okay, in this if we discuss about a theoretical method for this, we have formula for theoretical method. We have formula Q is equal to V into AS. Okay, or you say Q is equal to N into VA into AS. Basically V is equal to N into VA. Okay, where VA is the actual flow of velocity. VA is actual flow of velocity, and our N is porosity. Okay, so this is the formula, and this is for theoretical method. If we discuss about practical method, then we have a first test, pumping test. Yeah, so in pumping test we have formula Q is equal to K into I into A, and if you modify it, you'll get Q is equal to K into S by L into A, or say you say Q is equal to K into SA. K Q is equal to C into S into A, where C is equal to K by L. Okay, this is from pumping test. If our next test is recuperating test. Recuperating test. In this we have a formula for discharge. Q is C dash upon A into S. Okay, where we have formula for C dash upon A. We have formula for this, that 2.3 by T into log S1 by S2 to the base 10. What is this S1 and S2? Basically, S1 and S2 are depression head at T1 and T2. S1 and S2 are depression head at T1 at T1 and T2. Okay, obviously T1 and T2 respectively. And this C dash A is specific yield. Okay, so do remember these formulas. So this is it, a practical method. These two tests, pumping test and recuperating test. Let's move on to next thing, that yields of wells. What yields of wells? Yields of wells. So yields of wells, we have first thing in this for unconfined aquifer. Unconfined aquifer. For this we have formula. We have formula that Q is equal to pi K H2 square minus H1 square upon 2.3 log R2 by R1 to the base 10. Okay, and for confined aquifer, now next thing, confined aquifer. For confined aquifer we have formula. Give me a second. Confined aquifer we have formula Q is equal to 2 pi T S1 minus S2 upon 2.3, again the same thing, log R2 by R1 to the base 10. Okay, so this is it for confined aquifer. And for K we also have a formula for K, that K is equal to 2.303 by T 2.303 by T into A into log H2 by H1 into log H2 by H1 to the base 10. Okay, and for one thing in that, one keyword, that transmissibility is equal to K into Z. Remember this. Okay, so yeah, this is about the yields of wells for unconfined aquifer and for confined aquifer. So for unconfined aquifer, it's formula that pi K into H2 square minus H1 square upon 2.3 log R2 by R1 to the base 10. For a confined aquifer, this formula is Q is equal to 2 pi to T into S1 minus S2 upon 2.3 log R2 by R1 to the base 10. Okay, let's move on to our next thing, that for to calculation of head loss caused by pipe friction. Calculation of head loss caused by pipe friction. So calculation of head loss caused by pipe friction. Okay, so yeah, so in this we have first thing, that Darcy law, very famous law, that Darcy law. For this we have head loss HL is equal to F dash L by D into V square by 2G. F dash L by D into V square by 2G. Okay, where this F dash is friction factor. It's friction factor. Its value is vary from 0.02 to 0.0. Its value up to 0.02. Okay, its value approx 0.02. Yes, most of the time its value is equal to 0.02, and here v is obviously our mean velocity. V is our mean velocity. Okay, so yeah, this is about the Darcy law, and our next thing, that Manning's formula. Manning's formula. In Manning's formula, we have formula that v is equal to 1 by n r power 2 by 3 into s power 1 by 2. Okay, all or you, if you wanted to modify this, you'll get v is equal to 1 by n r power 2 by 3 into hf by l to the power 1 by 2, where s is equal to hf by l. Okay, this is from Manning sides. And next thing are Hazen-Williams formula. Hazen-Williams formula. Okay, in Hazen-Williams formula, we have formula that v is equal to 0.8 into ch into L power 0.63 into S power 0.54. 0.54. Okay, here S is equal to, you say, head loss HL by L, and our this CH is roughness coefficient. Roughness coefficient. Okay, and we also have a modified Hazen-Williams formula. So it's modified form. Modified Hazen-Williams formula. Williams formula, that HL is equal to, here HL is equal to L into Q by CR power 0. Power 1.81. Oh, power 1.81. 1.81 upon 99.462 into D power 4.81. Okay, so this is a modified formula. In the form of V, you'll write this. If you put this value HL there, you'll get a value of V that 143.534 CR into R power 0.6575 into S power 0.5525. Okay, so remember these formulas. This will help you to solve numericals. We'll directly put these values given in the numericals and usually get the values of V. Okay, so yeah, this is it of calculation of head loss. Let's we move on to next thing, that computation of water hammer pressure. What? Computation of water hammer pressure. Computation of water hammer pressure. So in basically we denote it as H max. So H max, we have formula that H max is equal to CV naught by G. Okay. So, and this C is velocity of pressure actually, is a velocity of pressure. And in this computation of water hammer pressure, if actual time T greater than critical time, then actual water hammer is reduced approximately to the proportion of Tc by T. That in this, give me a second. In this, if actual time T, if actual time is greater than critical time, actual time you said T greater than critical time Tc, then actual water hammer is reduced to, then actual water hammer is reduced to approximately in the proportion of approximately in the proportion of Tc by T. Okay, that is H dash max. Sorry, let's write it clearly. H dash max is equal to H max into, shit man, what is this? Wait a second. That H dash max is equal to H max into Tc by T. Okay. So if actual time, this is when actual time is greater than critical time. Okay. And here are this C value. We also have formula for C, that C is equal to under root EW upon rho W into 1 upon under root 1 plus EWD upon EPT. EWD upon EPT. Okay. Generally, this EW upon this factor is equal to, give me a second. Generally, this EW upon rho W, its value is approx 1433 meter per second. Okay. And this what is and this EW is basically bulk modulus, is bulk modulus, and its value is 2.07 into 10 to power 8 kg per meter square. Okay. And this EP is modulus of elasticity, modulus of elasticity in kg per meter square. Okay. And this is our wall thickness. So T is our wall thickness of pipe. So yeah, this is all about computation of water hammer pressure. And one more thing is that for calculation of G, that according to Government of India manual, according to GOI manual, this C value is also calculated by the for using the formula that according to GOI manual, we again have one formula, that 1425 upon 1425 upon under root 1 plus EWD upon EWD upon EPT. Okay, so yeah, this is all about computation of water hammer pressure. And one more thing in this source of water and its conveyance, that economical diameter of the pumping, that economical diameter of pumping. So this for this we have formula that D is equal to 0.97 to 1.22 under root Q. Okay, so this is it in source of water and its conveyance for great point of view. This is all about numeric things of a source of water and its convenience. Soon we will discuss previous year questions of these things. Okay, till then, do a lot of questions of gate examination and take care of yourself. And thank you so much for watching this video. Okay, thank you.